Hello everyone. Now that we have understood the basic idea what cement is, let's go into the depth discussion of the constituents of cement. This is quite important not only from the exam point of view but also to get a better understanding of the working of cement. So, to get an idea that how the properties can be modulated by changing the concentration of any constituent and to what extent. So, let's start. Basically, cement comprises of three main constituents like lime, silica and aluminium. There are others also, but the concentration is so minor and their effect on properties of cement is either adverse or negligible. But care has to be taken for them in order to control them like iron oxide, magnesia, soda or potash sulfur trioxide, etc. The relative proportioning of these is the reason for the properties of cement like setting time. Following are some examples which are increase in the free lime beyond certain limit which makes it difficult to completely combine with each other. The alkalis accelerate setting of cement paste. Fine lime will exist in clinker and will result in the unsound cement. Increase in silica content at the expense of alumina and ferric oxide makes cement difficult to fuse from the clinker. As you have been told earlier that there are various types of cement, now you have learned enough to be told that these types of cement are nothing but the results of modifying the proportion of any one or more constituent with respect to each other, so as to gain our desired properties. We will discuss the basic, that is Portland cement. In Portland cement, the lime or CaO consists of 60 to 65% of the Portland cement, which is an average of 63%. The silica, which is SiO2, has an average of 20, whereas alumina is 6%. Also, iron ferroxide is 3% and magnesia is 2%. Soda or potash also is having 1%. Now, the sulfur trioxide has an average of 1.5%. So these are the constituents which comprise of the chemical composition of the constituent of Portland cement. Now, after the constituents, we will discuss their effects on the properties. Firstly, lime. It is very crucial because too much lime will cause the cement to be unsound and we will get it to expand and disintegrate, and in scarcity it will lead to decrement in strength and will make it set very quickly. Lime, also known as CaO, provides strength and soundness to the cement. The deficiency of lime makes the setting time lower. Now, let's talk about silica, which is SiO2. This is also an important ingredient of cement as it gives strength to the cement due to the formation of dicalcium and tricalcium silicates. In excess, it increases the strength but also increases the setting time. Now, let's talk about alumina, which is Al2O3. It imparts quick setting to the properties of the cement. It acts as a flux and it lowers the clinkering temperature. However, the high temperature is necessary for the formation of suitable types of cement. Hence, alumina shouldn't be present in excess as it weakens the cement. Now let's look at iron oxide. Iron oxide, when heated, melts easily. Hence, the main function of iron is acting as a flux. That is, it helps in the fusion of different ingredients. Also, iron gives color to cement. If present beyond a specified limit, it hardens the cement. Now we'll talk about magnesia or MgO. The main function of magnesia is to impart hardness and color. Excess quantity of magnesia causes unsoundness in the cement. Lesser the magnesia, we will get an improved soundness of the cement. Also, if we talk about sulfur trioxide, which is SiO3, excess of it makes the cement unsound. Now let's look at soda or potash, which is Na2O plus K2O. These are impurities which arise from shale, clays or fuel, which are used in the manufacturing of cement. Alkali excess reacts with gypsum, which is used to prevent flash set. If present in amount beyond a specified limit, it causes efflorescence and cracking. Now let's look at alkalis. Most of these are carried by gases during heating, and cement retains a very less amount. In excess, they cause a lot of problems like efflorescence, alkali aggregate reaction, and staining when used in concrete brickwork or masonry mortar. Alkalis accelerate the setting of the cement. The variation in composition largely depends upon the ratio of CaO to SiO2 in the ratio material. Small percentage of iron oxide produces highly silicaceous raw material which is easy to burn. However, if these are in excess, a hard clinker is difficult to ground is produced. Now let's look at some additional info about the constituents, which are as follows. The rate of setting of cement is controlled by regulating the SiO2, which is Al2O3 plus Fe2O3. When heat of hydration is undesirable, silica content is increased to about 21% and the alumina and iron oxide contents are limited to 6% each. Resistance to sulfate water is increased by raising the silica content to 24% and reducing the alumina and iron content to 4% each. Thank you for watching this video. Please stay tuned to Ekeeda and do subscribe our channel.